Hmm.
Hello, may I ask a question?
Yeah.
I have a question on the last like word questions that were
Mhm.
on data frame.
Sure.
So yeah, yeah. My main confusion is part one, where it says, "Do you notice anything unusual about vector character within data frame?"
Hmm.
Uh, so I ran a class of vector character,
Hmm.
and I got character, like the class character, and then I looked at just the vector itself, and it was a bunch of capital letters, so I wasn't sure what is unusual about it.
Hmm. Yeah. So occurs to me that there is in this case nothing unusual about it. So I just looked at this and I'm scrolling down it, and this is actually revealing something that has changed in the recent version of R that used to be a problem and no longer is. So you're quite correct in this and being like, I don't actually see anything unusual because it's behaving the way a person thinks that it probably should. In R version 4, it's like I realized I've updated this homework. This is probably the second term in a row I've to update this part of the homework because I don't make notes to myself. It used to be that if you took a character vector and stuck it into a data frame, it would convert it to a factor automatically. This is referred to as a strings as factors equals true setting. Well, one of the largest changes they made in R version 4.0, which came out this last year, I think. When did 4.0 come out? A little less than a year ago. They removed that setting, which had plagued people like me for many, many years. And so now you're quite right. There isn't actually anything unusual there, and I should send an email out about that while we're all sitting here. Otherwise, I will forget. So let me go ahead and do that.
Okay, I see, I see.
Yeah, 1 second. I will send that out.
Yeah, all my other questions are related to the last chunk of word questions.
Okay, 1 second. Let me send this, and then I'll field your next. Boom. Okay, there we go. Silly Chuck. Can't be trusted with these homeworks. Okay, so what was your next one?
It's about the name, so part two of the data frame questions.
Mhm.
Like I wasn't really sure what the function names actually does because it varies so much with whether it's a um whether it's a data frame, list, or matrix. So I think that from what I experimented with, for data frames, it gives us the names of the vector used, and then list, it gives us a vector of list element names. But I wasn't sure what was going on with matrices since for mine it just returns null.
Oh,
So
yeah, this is a funny thing. So, what names does is names returns the names of the individual elements of an object. The individual elements of a data frame are its columns. The individual elements of a list are its single elements because they only have sort of one dimension. Matrices are weird. Matrices don't have a names attribute for their individual elements. Instead, they have column names and row names. And so this is essentially the idea. What you saw there is the point, is that you can't do names on a matrix, but you can on a data frame, because fundamentally data frames are lists, so they behave like lists do. If that makes sense.
So I think what you're saying is that you can't do like names on matrices because they don't have a naming attribute, but you can assign column names and row names.
Yeah. And interestingly enough, I'm pretty sure row names and column names will return things off of a data frame. So data frames kind of pretend to be a matrix, that all the things that work on a matrix also work on data frames, but things that work on lists don't work on matrices. So it's this kind of this weird thing where with matrices, you wouldn't want to use names, but you could use names on a vector or a list or a data frame.
And since that lists and vectors, I assume they're one-dimensional, then they can't have like row names or column names, right?
Correct.
Okay,
Yeah.
makes sense, makes sense.
Anything else? Okay, then we'll go ahead here and get rolling. I'm just going to do this thing from scratch, right? So what I said, and the way it'll go with all the sort of future labs, we're just going to kind of work on these homeworks together and grind through them. I'm going to solicit answers from people, so you're going to have to work for it a little bit, but we will go through the entire assignments together. So to do this, this is assuming you're doing the R data structures one. I assume if you're doing the linear regression one, you're already advanced enough. You don't need me helping to walk through it. So what we'll do here is on the course website, all your templates are found here. So I'm just going to go ahead and grab, down here at understanding our data structures, you'll see homework 4. This is the structures are marked. I'm just going to go save link as, pop up a dialog box, save it wherever you want. It's basically self-contained, so it doesn't matter where you rely on any external. In our studio. Okay, now you should get something that looks like, is my audio here? 1 second. Why is my audio cutting out? Connected to the right Wi-Fi. Here, give me 1 second here. I'm going to see what's going on. Here it is. Let me turn on in the other room. Well, unfortunately, I think we're going to be dealing with that. So I just glanced out in the other room, and my roommate is in her own massive Zoom thing for the class that she's teaching. So we're currently on redundant massive bandwidth consumption. And despite the fact that I'm on gigabit fiber optic, which should be trivial with this, Zoom is terrible. And it tends to do bad things when multiple people are using it simultaneously on the same connection. So hopefully it will be okay. Actually, there's a suspicious thing right there. So I'm actually getting not a proper connection to my Wi-Fi router, despite it being 10 feet away. That's very odd. There's probably actually, maybe there's band interference going on. Well, I don't really want to sit here and troubleshoot Wi-Fi bands in the middle of the lab. So hopefully it won't be so bad as we go. If you need me to repeat anything at any point, just let me know. I'm perfectly happy to repeat it. Yeah, the problem with joining in by phone is I got to, well, I guess you'd have good audio that way. I could turn it off and just screen share. We'll see what happens. The other thing is I'm sitting here like screen sharing. I've got a million videos going on. Anyway, hopefully it works. So we've pulled down this our markdown template here. I'm just going to go ahead and normally what you want to do is fill in these fields up here, something like that. Now, when you get this R markdown template, an important thing is to follow the things written in them, like do not edit anything in this chunk. This huge, ugly chunk filled with terrible looking code is actually the auto grader for this assignment. So this is the thing that is used to check to make sure all your answers are correct as it goes through the assignment. You don't want to know how any of that thing works. Okay. But if you're interested, you can see, and theoretically, you could probably reverse engineer every single answer in here without having to think about it using the auto grader. But if you're at the point of sophistication where you can do that, you would just be much faster to answer them directly. Anyway, okay. So the gist of this template-based assignment is we're just going to kind of go through what sometimes look like relatively straightforward answers to basic questions about different objects that we talked about on lecture Wednesday. Okay. So to do this, we're just going to fill in code in designated locations in the chunks. You don't need to create any new chunks. You don't need to edit any options. You don't have to mess with anything. You basically just follow instructions and we fill in answers at each particular line. Okay. You can also fill in text for the quote, like the text answers below things. I'm not really going to go over those. I'm going to focus on the coding sections and leave those sort of thought answers to you. Okay. So the way this thing works is anytime you knit, it will run all the code in here, and then it will attempt to check your answers. If I scroll down to, for instance, the first section we're going to fit answers into, I scroll down to the bottom here, it's going to say no code entered yet for any of these questions. Okay, I haven't entered any code, there's nothing yet. But what's going to happen is as we put in each answer, if I knit this document, it's going to check the answers and give me suggestions if I get it wrong or tell me I got it right. Okay, so here on out, you're going to have to provide me with answers. I'll help you work through them, but you're going to have to provide. So this first question here says, use the function seq to create a vector of 10 numbers evenly spaced from 0 to 15. Do we know how to do that? It's two key pieces of information here. It's a order is the range is 0 to 15, but the other part of it is that there should be 10 numbers. So how would we go about doing that? Feel free to type stuff in chat or say it
out. The first thing I did was to put in a round in the first part.
To do what now?
Oh, I did round first and then did sequence.
We don't want to round it. We want to leave it alone as it is. Because if you round it, you're going to end up with less decimal points than you want, and it's not going to come out with quite the right answer. But yeah, so sequence, SEQ, and I see there's a few of them in chat too. So there's a number of them. So we see one that's sequence -16 by 175. I'm not sure what. So if I do -16 by equals 1.75, probably not going to get what we want here. This is going to produce this result here, -1,075,25,425,6. I'm not sure what you were after, if that was a typo there. The next one I see here is, okay. So this one right here that I see in chat from, is that Cosette? Is that how I pronounce that? Cosette? Don't like butchering people's names. Yes, so, okay. So this one right here says, take a sequence from 0 to 15 and critically says length.out equals 10. I see a couple other people have mentioned the same thing there. There's also a clever solution in chat a couple of people have used that probably also gives the correct answer, right? Yeah, the 15 divided by 9 solution. So this one is going to produce this. It's a sequence which begins at 0, it ends at 15, and importantly, as you can see by the bracket 10 here, this is its 10th element and its last element, so that it is a length 10 vector from 0 to 15. The other one, which is a clever solution here, if you don't know about the length.out, but you can do some math, you could say by equals 15 divided by 9, And you're going to get exactly the same answer in this case, because this is a fraction that divides up nicely enough for R to be able to basically handle. I would not be surprised, however, if these in fact are not equal. They are. Okay, so the rounding works out in our favor in this case. So in this case, those are equivalent, and that is basically probably what under the hood R is actually doing. You could use either of those, but I would highly recommend the way that is sort of the way you should try to remember is sequencer thinking length.out equals 10 is the most direct way of doing it. That's allowing R to figure out how to come up with the fractional increases for you, and you just worry about the range and the amount of numbers you want. Any questions about that? Does that make sense? Does anything that didn't work for you not make sense why it didn't work? Okay.
I had a question.
Mm-hmm.
So the length dot out, is that the same thing as just writing length? Because I got the same output if I just write length as the argument.
Yes. So this is a funny thing, which I don't talk about much in this class, and I highly recommend not taking advantage of. R has a thing where if you give an argument to a function and it has an ambiguous argument, like this argument doesn't actually exist to sequence, it will try and find an argument that does exist that this is a component of. So what it's actually doing is it says there isn't a length argument to sequence, but I'm going to go hunt and see if there's some argument like length.out, and then it goes and assigns this 10 to that. I find that really confusing and undesirable. So I don't talk about in this class, but it's actually doing a type of ambiguity imputation for you. So it works in this case. The problem is if you're with some function where maybe there's a length dot out and a different length dot something else, or if there's a length and a length dot out, and you actually wanted length dot out, I usually try and make sure to use the precise arguments, but it does work in this situation, rather surprisingly. Does that make sense?
Yeah.
Okay. Yeah, that's a weird thing R does, and a lot of modern functions block that functionality because it's considered kind of bad, because it can create confusion. Okay, the next one. Use colon to create an integer vector of the numbers 11 through 20. This is not a trick question. How do we do that? Yes, yes, 11 colon 20. Okay, we do that. And just as an example here, I'm going to, I'm going to run it as I go. Okay, if I've run these two lines here, if I went down and ran these, it would say, good job on Vectonum, good job on Vecient. I got those answers correct. If I went up here and changed this, like I accidentally said, from 10 to 20, run that line and go back here, it would say, oh no, check your code for vec integer. You have the wrong length or dimensions, and you seem to have an incorrect or misplaced value somewhere. That's it saying, basically, I'm seeing a couple things that are wrong. This first one is probably the big one. So this is how the answer checking sort of works. If you knit it, you get the same thing. Just takes a little bit longer. So here we'd see I entered the code here for vecnum and for vecint. I come down here, good job on vecnum, but bad vecint code because I changed that value. This is how the answer checking works. I'll check every few answers instead of every single one because I will know which ones are correct, because this is the 8th or 9th one of these labs where I've gone over this homework before. So I remember all of the answers, burned forever into my brain. Okay, so continuing on. Number 3 here. Use letters, all capital letters, and brackets to create a vector of the last 10 capital letters. How might we do that? Now, if you're working on your own, we might do something like first take a look at what letters is, just to get an idea. Letters is all of these letters. So if we want the first 10, so it says to create a vector of, the last 10 capital letters. So here are some interesting solutions. So first we've got letters 17 through 26. I do letters 17 through 26. I get Q through Z, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is the last 10 letters right here. This is an interesting one So this one, take letters, go -1 to -16. Does this work? It does. That's awesome. Okay. I hadn't thought of doing a negative sequence like that. So what this is actually doing is this is subtracting the first 16 letters from the alphabet. That's a novel solution and one I don't usually see in labs, but it's completely valid. It obviously produces the exact same result. Here's another one. This one doesn't use brackets, but it does work in this case and might be the fastest way you thought of it, which means it's a good answer. You could say, okay, I'm not using brackets, but I know a shortcut for this. I know if I do tail 10, it's going to give me the last 10 items or something. Okay. So you could use any of these solutions here. The homework says use brackets, but I don't mind. Tail 10 here, it works perfectly great. Tail 10 works as long as you want some numbers all the way up to the end of something. It's going to do the job. I'm just going to do this first one here, but these are all equivalent. All of these are correct. Yeah. Okay, do that. I know it's correct. The next one, use letters, lowercase letters, and brackets to create a factor variable using the first 10 lowercase letters. This is a two-part one. There's two things you want to do. You can give me the whole statement or give me a part of it. There we go. These are both going to give us the correct answer. Well, actually, the first one, do I say the first 10 lowercase letters? You probably, well, if you do this first one, let's see what we actually get. So the thing about this one beginning at 0 instead of 1, do you code in other programming languages like Python or something that indexes on 0?
Yeah.
Yeah, that makes perfect sense. Yeah, so in this case, it actually returns the correct result because if I subset this on 0, it gives me nothing, probably. Yeah, it gives me nothing. So by subsetting on 0 through 10, it's actually only giving me 1 through 10, and nothing is being produced for the 0. It actually gives you the right answer, but it's kind of weird because it's exactly the same thing as 1 through 10. This is R not believing that 0 indexing is a thing, which is fine. Okay. The next one, as dot factor, is basically exactly the same thing. As dot factor letters 1 to 10, you're going to get the same result. The difference between as dot factor and factor is as dot factor doesn't have as many options as the factor function. It's just meant for converting something into factor, whereas factor gives us a couple other options. So factor over here, you can actually this help file here, put that right there. Okay. Factor takes a whole bunch of arguments. It takes some data, but we can also give it levels, labels, tell it it's ordered and stuff like that. Whereas as.factor doesn't take any additional arguments. It still works. Okay, yeah, if you want to be silly, we can take the uppercase one and convert it to lowercase and do it. That'd be good if you didn't have the lowercase one. That's kind of a funny one. In that case, you don't actually need the C in there, though. You could do it without the combination. We could just go boom, boom, and that'll do the job. So we can also do fun solutions too. Okay, but I'm just going to take, let's see, just kind of this factor. I said with letters 1 to 10. Is that the one in there? That's basically a combination of both your answers because they are both correct. All of these give us the correct answer. We will take all of them. Okay. Next one here, use C to combine vec character and vec factor into vec letter. Do not convert it to a factor. So how would I go about doing that? So I think that's the next one. The first one, how do we combine vec character and vec factor into vec letter? I will probably use that next one though, because that looks probably correct. Yeah. So it's super simple. If you want to combine two vectors together, just combine vec character and vec factor into vec letter. Okay, I'm gonna make sure these have all run up here. Vec letter should then look like this. It's going to be that Q through Z we created earlier, and then 1 through 10. Why does vec factor look like a 1 through 10 here? Does anybody remember? So look at vec fact. Looks like that here, but as soon as we combine it with vec character, it pops out as numbers. You remember this? Nobody. It's one of the great mysteries of factors. Factors are not these values you see here. These values you see for the factor are its levels. Underneath the hood, hidden from your sight, the actual values of vec factor are these. The numbers 1 through 10 that correspond to the levels. A is level 1, B is level 2, C is level 3. When you combine a piece of character data and a factor, it discards the extra information that is the labels on these things and returns only their levels. This is an unintuitive thing that's good to know about. If you combine factor and character, you probably are not getting exactly what you want. You normally would convert it to character first. If you say, however, here as dot character, vec factor, it converts those levels into their labels, which means, oddly enough, if I take this combination here, vec character, vec factor, and I explicitly say as dot character, vec factor over here, it gets probably what you would expect. This is one of those oddities of R, just good to know about. Okay. The next one, I believe Jenny had an answer right there. Yeah, okay. So the next one is straightforward. Next one says use C in combination with square brackets to combine the first 4 elements of Vectonum with the last 4 elements of VecInt. I'm going to expand this just a little bit. There we go. To create VecNI. Well, that looks pretty good to me. This is saying take vecnum elements 1 through 4 and vecint elements 7 through 10, and then combine them together into a single vector, which should give us something that looks like that. I think that's probably correct. I am pretty sure. Once we get to the end here, I'll check them all and we'll make sure things look good. Lastly, use reverse to reverse the order of vec factor and assign it to facvec. Should say and assign to facvec. Why do we do that? So those non-trick question ones. Just want to show you this command. Okay. So in this case, I don't know, doesn't make a difference. So vecfac is already a factor. If I reverse it, it should still be a factor. Yes, it is. Okay. So you don't actually have to explicitly make it a factor again. It will stay a factor. So you get the identical result with factor, rev factor as you would with just rev vecfac. Okay. So that just says reverse it. And we're good. I'm going to knit this. If you have any questions on this section, let me know. Happy to go back. We're in no hurry today. Good job. It's nice to feel praised for our hard work. Yep. Okay, pretty happy with that. No lingering questions about that stuff. Okay, we will head on out. Okay, like I said, I'm going to skip over the sort of question ones to sort of like think about yourself and answer it. I'm not super concerned with you getting these things right. This is really just to make you engage with them and sort of mull it. So I don't want to just provide you the answers. Now we'll move on to coding with matrices. So first one here. Use matrix to create a matrix with 10 rows and 4 columns filled with NA values. So we know what function we're going to use. It's just a matter of what's going to go in there. I like this. Let's see. It says matrix data equals NA, number of rows equals 10, number of columns equals 4. What I like about this one right here is it straight up tells you exactly what we want to know. We want a matrix, makes a matrix. We want it filled with NAs. The data is going to be NAs inside of it. It has 10 rows. The number of rows is 10. It has 4 columns. The number of columns is 4. Matrix at least has a nice syntax to it. So we could say here that we get a 4-column, 10-row one. Now, this is an excellent statement here, or question in chat. Do we need the data part? Can it just be matrix NA and row 10 in call 4? Yes, it can. And the reason for that, if I do question mark matrix, is that the first argument to matrix is data. That means if I just give it a value here and I don't say data equals, it will give me the same answer. In fact, because n row is the second argument and n call is the third argument, we could actually say data NA, nco, like that, and it will give us the same answer because it was assuming we're giving the arguments in the order they exist in the function's documentation. So this is me saying NA is the data, the number of rows is 10, and the number of columns is 4. So you could do that. Another thing we could do is I could leave the n row and n column like that and not provide data at all because data defaults to NA. So we could also just provide the columns and the rows and we get the same answer. A lot of flexibility. You can do what you want. These are all correct answers. My favorite is being explicit about your arguments. And so I like data equals NA here. But they're all completely equivalent. If I'm writing my own code, I write whatever requires the least typing. So in this particular case, I'd probably do NA10.4, but that's just me. Okay, so next one, assign Vectonum to the first column of mat1 below. Okay, so on this line right here, what do we need to do to assign Vectonum to the first column of mat1? Note you're going to have to change things on both sides of the assignment operator. That's a great answer to me. So if that's the intuitive one to you, that's great. That's the one that's intuitive to me too. This is saying here, I am going to assign something to the first column slot in this matrix. What am I going to assign to it? I'm going to assign Vectonum. I run that, and I run that. Mat1 is now a matrix where its first column contains all of that vector Vectonum. Not only is this to me the most intuitive way, it's in fact basically what I would say the cleanest or only clean way to do this. This is probably the best way to do it. If you want to just go straight to that first column, this is the easiest way to do it. I'm actually trying to think off the top of my head what is some other not completely ungainly solution to that. You can use cbind to do it, but it'd be kind of awkward. Okay, next one. Assign vecant to the second column. This is basically repetition of the basic idea. What do we have to change to get that to happen? Anybody else? Let somebody else snack this one. Give me time to drink coffee, look at my phone. Yeah, basically the same idea, right? So the only thing we really got to change is the location we're assigning to, right? This says we're assigning to column 1. Well, why not assign to column 2? Then we just say, let's put vec into them. So here's something, this is sort of what I was saying in earlier. You could do some odd things too. So I did it the hard way, which is I cbind these things together. So basically something like that. In this particular case, I will note, technically you don't need the C's here. The C's are for combining two things together. You know, if you put one thing in a C, it means it's probably not doing anything. But in this case, you could do it. This is going to get you a similar answer to the one before, but not exactly the same answer. Notice the difference here. If I run this, okay, mat2 looks like this. Cbind one looks like this. Do you see the interesting difference here? Okay. So by directly assigning the vectors to the column slots, they don't get the names. But if you cbind named objects together, it keeps the names and makes them column names. It's the same data item, but this is a very subtle difference between these two operations. So it isn't exactly the same thing. It's just something unique about the way cbind works. Okay. The actual values though are identical. So if I say this equals mat2, it's going to say all of the values here are true. And then because it's NAs and the other ones, it can't compare them. But these things are actually equivalent. In fact, I could probably say this. Yeah, and they're completely equivalent. Okay. Yep. This is the way that I would say is the best way to do it. And it's good to get really good at using brackets. Basically, if you're going to be living in the R world, you're going to need to know how to use the square brackets all the time. So practice with them, kind of get to know them, and ask questions. My use of brackets doesn't make any sense. Brackets are very important for doing these sorts of little operations. It's a lot of things you can't do with cbind. You can kind of kludge together a solution there with cbind, but brackets are often, there's things that are really hard to do. Like if you want to change a single value in a matrix, there's basically no combination of cbinds and rbinds that's going to get you that. Okay, next one. Assign vec character and vec factor to the third and fourth columns of mat3 using a single assignment operator. This is where that cbind might become useful. Let's see. Oh, that is a solution that works for an odd reason. Okay, so I love this. This is great because this is an unintuitive one that this works. If you think about it, it's unintuitive. So the reason I'm saying this is unintuitive, you're like, it works, but why? Look at this object over here, mat3, which I haven't created yet. So don't look at it. Now look at it. So mat3, the dimensions of mat3. mat3's dimensions are, it has 4 columns and it has 10 rows. What's the dimensions of this thing you're assigning to the third and the fourth column? Well, this thing here, vec character, vec factor, it's not a matrix. It is a length 20 vector. So why is it that we can assign a length 20 vector to an open space of 2 columns and 10 rows? Okay. Do you see why that's kind of a strange thing? These are very different objects over here. This is a matrix over here. This is an object here. The reason is that if you assign a vector to a matrix over here, it will populate the slots of the matrix just as if you were creating that matrix from scratch with a matrix function. And if you remember, by default, matrices populate things by row equals false, which means basically it's filling up this matrix by putting Q here, R here, S here, and so on until it gets through 10 of these things. Then it goes to the next column and populates it. What it's actually doing is running through this vector, filling in slots until it runs out of space in it, and then going to the next column and so on and so forth. In this case, it ends up working perfectly fine. Whoops. So if I assign that to that, mat3, it works. But there's another way to do this if you want to be explicit about your dimensions. So if you want to assign something to a 2-column, 10-row matrix, why not create a 2-column, 10-row matrix of things to put into that slot? How might we do that? How might we turn vec character and vec factor into their own matrix that fits into that space? Have an idea? How do we take 2 vectors and make them into a matrix? This is where Katie's hard way becomes the easy way. So if we look at her answer before, she used cbind with 2 vectors and then some NAs. If we do the same thing, cbind vec character and vec factor, it's going to make a 2-column, 10-row matrix, which is the exact same dimensions as this thing over here. We can assign to it. We get the same answer. Okay. The only difference here is we're being explicit about exactly how we want that thing to happen. These answers are equivalent and equally valid. The one big difference is that vector example. So using C instead of that would not work if this thing over here was a data frame. Let me show you. Let's assign mat3 as a data frame. I'm going to show you. Test 3. This looks basically exactly the same as what we had before. The format is slightly different because it's a data frame, but contains all the same data. Okay. So let me actually run that there, that there. Okay. Built like that. If I attempt to say assign this to, so test 334 is that same, did not display that? Oh, because it's displaying at the bottom of this. Okay. Test 3 is these NAs. If I attempt to assign this vector to it, what are we going to get? Oh, it works with default data frames? I have learned something new today. That should not have worked. I'm so used to working in tibbles. A tibble would scream at me, I bet. Let's see. That work? Okay. That'll scream at me, right? Yes, it will. Okay. Can't assign columns to the end with non-consecutive locations. I've lived so long in my tidyverse world, I forget that base R still lets you treat data frames just like a matrix. Well, disregard everything I said. There's our equally valid solutions in base R. Okay. This one, though, is technically the one I was looking for and will work in all situations, so it's slightly safer to use. So either way. Okay. So next one, sorry for the confusing tangent, which turned out to be unnecessary, as I often do. The next one here is select the fourth row from mat3 and assign it to the object row 4 as a vector. How would I select the fourth row of mat3? I like it. Yeah, both of those. Mat3, select row 4, all the columns. That just gives us that first or the fourth row of the data. I assign it to row 4. Make sure I run the rest of these too. There we go. Okay, I like it. Next one. Assign the element in the 6th row and 2nd column of mat3 to val62 as a numeric value. So how do I go about doing that? This is a 2-stager. First thing I need to do is I got to get that 6th row and 2nd column element out of there. Nope, there you go. You've done it all in one. I'll show you the 2-stepper. So the first thing is we got mat3, right? What we want is we want the 6th row, okay, and we want the 2nd column, which should be the number 16, but it's quoted because our matrix is a character matrix because it's got all this text in here. So the first thing we're going to do is say mat3, 6, 2. If I run this, it's 16, but it's quoted because it's a character matrix. If we want it to be numeric, as Jenny suggests there, as .numeric, and that will convert it to a number and give us val62 as a numeric length 1 vector. Okay. So the next one, this one's not a trick question, just involves typing a bunch of things. Use cbind to combine vecnum, vecint, vecCharacter, and vecFactor into mat4. So it's sort of an unambiguous one. Just going to kind of do it. Combine vecnum, vecint, vecCharacter, and I can't type, vecFactor. This is just me forcing you to recognize you can put an arbitrarily large number of arguments into cbind. You can put as many vectors as you want in. It will make them all in order columns of a new matrix. This gives us the exact same result as mat3 earlier, but as I showed you earlier, we get
column names corresponding to the names of the objects given to cbind. That is the little unique feature of cbind versus creating a matrix and manually assigning to each column. Okay. Next one. So this is a complicated one. Okay. So this one says here, first transpose mat4 and then select only the first 4 columns and assign it to mat-t. So order of operations is important here. How would I go about doing this? So you're not supposed to use cbind instead. So you've got the general right instinct, but there's one thing about this that's slightly off. So your suggestion here is to say, okay, I have a transposition of mat4, and mat4 is subset to its, oh, so I see you did it with the rows. Does this give us the right answer? That might be the right answer. What would be the way to do this by obeying order of operations? So if we want to transpose it before subsetting, what is the one thing we'd have to change here? We can move a single thing to do the transposition before the subsetting. So that's the same thing, kind of the same thing. The C is unnecessary in that one. How would we make it so it transposes it first? Yes, that is what I was looking for. I like it. Okay, so what's going on here is the way R works is you can chain together these sorts of like functions kind of like arbitrarily. This right here is saying, let's transpose mat4. It does that operation, and then the result of that you can subset. So this gives us, what's funny is it's probably, is it the same result? It is the same result. Okay, so what's funny is this is the clever, Jenny did a very clever thing right here, which I wouldn't have thought to do. She did the transposition second, but because she selected the rows instead of the columns, it's the exact same operation because transposition swaps your columns and your rows. So you could subset the rows, then transpose, and it's the same as transposing and selecting the columns. That's a fun way to play around with that. They're the same answer. I like them both. This is the spirit that I was looking for, but I appreciate this one for being very clever. And they are exactly equivalent. Exactly equivalent. Okay. That's why I love programming classes, because everybody just brings to the table some interesting solution that gets the exact same thing. And if that's like the way you think about it, do what occurs to you first if you get the right answer. Okay, so does this make sense here why we're doing, like what this is doing? Do we know what the transposition is doing is a good thing I should ask first. If this is mat4, mat4 looks like this. This is what the transposition of mat4 looks like. So mat4 has 4 columns and 10 rows. The transposition of mat4 has 10 columns and 4 rows. All we've done is we've swapped the row and column locations. The data are in the same coordinate locations, just with the swapped rows and columns, right? So something that was in position row 1, column 2, vecint is now in row 2, column 1, right? On something that's square, it's actually like you took the square and you flipped everything onto the diagonal of the square. Okay. Very common, very useful operation to be able to perform if you're going to be doing almost anything statistical by hand. In R, and by hand, I mean you're doing things like, well, if you're doing the linear regression assignment this week, you'd be doing a bunch of transposition. Okay, so this is equivalent to the other one. I'm doing this one because it's slightly more readable to me, but honestly, they're exactly the same. Make sure I ran that one too. Next one. Last one, use rbind to add the rows from mat3 to this prior thing. That is, add mat-t first, mat3 second, and assign it to mat-big. What does that probably look like? Not a trick question. allergies murdering me today. Open the window for a minute and spring assaults me. So I don't go outside. So what do people have for this? Yep, I like it. We are buying some stuff. We're going to take Mat T first. We're going to take Mat 3 second. Look at this. It's made a big, ugly matrix. Okay, this is the transposed one up here. You can tell because it converted its old column names into row names because the columns and rows traded places. And then this is the original matrix down here. So we just stuffed it together into one big, meaningless mess of crap. Okay, I'm gonna knit this, make sure I didn't mess anything up. Always important to do. Good job. I'm excellent at answering a homework that I wrote myself. Okay. So, the dulcet tones of the cat. Meow. Okay. So, next one. Let us move on. Okay. So now we're going to move on to the list section. Lists can be a little bit of a mind bender. So this is sort of the hard section of this homework. The climax of the homework. Try to have something easy afterward with data frames. Okay, so first of all, use the function list to create a list that contains, come to me, Fluke. You're just gonna scream at me. What you doing? Oh. I like when a cat simultaneously really wants attention, but doesn't want to be touched. And so she's like hovering right there and is just like, stay away, but don't stay too far away. Yeah, I was going to try and show you the cat, but she's in her box and her box is her defended territory. So she's just like, no, you can't get me. But she does want to be pet, just not picked up. So when she gets up, I'll show you the cat. Yeah, that's the light. That's the cat. Okay. She just wanted to be inside. The door is closed, and cats tend not to tolerate such transgressions. So everything's fine now because I pulled her box near me, and she's like, okay, now it's fine. So what we're going to do here is use list to create a list that contains Vectonum and row 4 and assign the names Vectonum and row 4 to these elements of it. So how would we make a list of Vectonum and row 4 or do the whole thing? What's that going to look like? I've once or twice showed how you name things at the same time in a list. It's not too tricky. Got any ideas? It's okay to not be sure. That's what we're all here for. These are tricksy. They're harder. Anyone have a guess at this? Even without the naming part? That was pretty good to me. Let's see. Just gonna copy that. Tired of typing stuff. Okay, so what we got here is we're gonna make a list. We got something named Vectonum. It's gonna be Vectonum. We got something named row 4. It's gonna be row 4. If I put this in my console to show you, what we're going to end up with is something named Vectonum that contains the values of Vectonum, something named row 4 that contains those values of row 4. Okay. Now, an interesting thing about this, it applies to both lists and data frames, is you don't actually need the quotes, but it works with them. You get the exact same thing with or without the quotes. That's weird, but you don't need them. It just works with them, with or without them. Works either way. So you can do it either way. And yeah, that is exactly what we want. If I don't name them, so if I don't have the left side naming, they would look like this and would just have numeric indices. So the names actually don't get auto-populated the way that they do with like cbind did earlier. Okay, so we can do that. And that gives us what we want. You'll notice that this syntax, especially if I show it without the quotes, This is actually looks a lot like the rename or select syntax in dplyr, right? We have the thing that we want to be named and the thing that that name is coming from. It's kind of that sort of general idea. Usually the final result of something that's going to be on the left side, same thing in mutate. Okay, so we got this. That looks good to me. If that doesn't make sense to you or anything about that doesn't make sense, do of course stop me and ask questions. I like answering questions. Next one. So using $, the extraction operator, extract row 4 from list 1 and assign it to the object row 4, 2. So how would we do that? How would I extract row 4 from list 1 using $? Yep, I like it. These all look good to me. List 1, $, row 4, autocomplete. So this says, go into list 1, find the thing named row 4, and spit it out for me as it's like, as the actual object itself, that is as row 4. We can do that, gives us what we want. Okay, next one. Create another list that contains val62 and matbig. Pretty straightforward. I'm gonna make somebody type it though. This is the inversion of giving like a lecture talk. So in lectures, what you do is when you need a minute to think, you drink from your water bottle or you cough and then drink from your water bottle if you need extra time. But instead, what I'm doing is making you guys think, well, I drink water. Okay. So I like these ones in here. So these are look good to me. You could name them or not. I'm happy either way. So I'll take this one right here. This one works perfectly fine. Yep. Just line these things up because I like the way they look. Also going to, just because I'm that sort of person who never quotes these, so I make other people obey my style. So we're gonna create another list. val62, matbig. That ought to, oh, matbig not found. 1 second. Make sure I get matbig. This little button here, this sneaky button in your chunks, runs all prior chunks to the one you're looking at to save you from going up and running code higher up. So you just saw me, I forgot to run the one to create matbig. So I press that. Now we good. List 2 should have val62, the lonely 16, and then this entire big ugly thing we created before. That appears to have worked to me. Okay. Next thing, combine list 1 and list 2 together using C and assign them to list 3. How do we do that? This is a use of C I don't know if I've demonstrated in class before. So C, right, is combine. Combine works on any kind of vector. Well, it turns out lists are a type of vector. They're not an atomic vector. They are a list vector. So you can use C to combine 2 lists together. And we'll get this monster. Scroll all the way up. List 3 contains Vectonum, row 4, val62, and matbig all at the same time. We just stuck, this was list 1, this was list 2, put them all together, and that's list 3. Okay. So you can assemble them just like vectors. Okay. The next one, use unlist to turn list 3 into a vector and assign it to vector 3. This is not a trick one. This is a demonstration of a strange thing. Okay, I'm gonna say unlist list 3. So what unlist does is exactly what that function sounds like it does. It takes anything that is in a list format like this and turns it from a list into a standard vector. Unlisting list 3 results in this. Now, if I've unlisted it, it is now a single vector, and its length is the length of every element of the prior list put together sequentially. So it essentially took these 10 elements here, then immediately stapled the next 4 to the end of them, this 1 to the end of that, and then all of these matrix elements, it broke them out column by column in order, and then stuck them all together to get one big, hideous vector. So unlisting is an operation you sometimes want if you have some sort of function that generates some complicated list structure, but the only thing you're actually interested in is the individual elements. What you can do is unlist it, and it just creates one big long vector of all the elements, and it discards all list structure, all that hierarchy, all that nesting from before. So again, to remind you, list 3 looks like this. List 3 has a lot of hierarchy to it, right? The overall list contains 4 separate sub-objects. These are the elements of the list, and then within them, they can have their own objects and stuff. In this case, for instance, this one has a bunch of different columns and a bunch of different rows. What do you think is going to happen if I unlist list 3 and then I make it back into a list again? Without looking, does anybody have a guess what's going to happen? Are we going to get all that structure back? Are we going to make it look like a nice hierarchical set again? Well, now you've had time to check. The sad answer is no. Once you've removed any hierarchical structure on something in R, you have destroyed it. It is gone. You will never get it back. And so this is an important thing to know about R. R tends not to retain knowledge of the things you've done to objects. You can't typically undo things except in certain limited circumstances in certain packages that have functionality for that built in. Some of the tidyverse functions actually have that, specifically for pivoting. They kind of build in some knowledge of the prior structure and can allow you to unpivot quickly, but it's quite rare. Basically, if you have a big list, it's complicated, you unlist it, you can't regain that structure easily. Okay. So we convert it back. There we go. Convert it back, and now all it's done is made every element of that vector into its own element of a list. Okay. So that's just to tell you, destructive conversion. You can't you don't keep that knowledge. It's not let's sort of look at it. There's no no homeopathic object creation in R. It does not retain a memory of its past state. Yes. Okay. So next one. Now copy list 3 as list 4 and use double brackets to assign list 3 as the last, that is 5th element of list 4. You'll notice there's a lot of text for this one because it's actually a simple idea, but I've had to explain it so many times over the term that I'm slowly narrowing in on language that makes some sense to people. So what we ought to end up with is a list object that has 5 elements. It should be named list 4. It contains the same 4 elements as list 3 plus 1 more element. That is all the elements of list 3 as one object. Okay, this is a 2-stage process. So the first thing we want to do, right? I'm saying copy list 3 as list 4. I'm gonna just go ahead and do that. List 3 is list 4. Okay, now, how can I use double brackets to assign list 3 as the last or 5th element? Okay, I see a good one in chat that shows you it's actually hard to explain in words, but easy to write the code to do. This says I'm gonna take list 4. I'm a subset to its 5th element, and I'm going to assign to that list 3. Now, let me show you what we get from this. If I run this, so if we remember, list 3 looks like this. List 3 contains Vectonum, row 4, val62, and matbig. Look at list 4. List 4 contains Vectonum, row 4, val62, matbig, and then its 5th element contains Vectonum, row 4, val62, and matbig. If we use structure to look at the hierarchy of this, its hierarchy is it has these top sort of elements, row 4, val 6 2 mat big, and this unnamed one, that's the 5th element. And then below, inside this filament 5th element, it has Vectonum, row 4, val 6 2 and mat big. Lists are sometimes easier to understand when you use structure because structure allows you to visualize the hierarchy of levels inside the list. You can put anything you want into a list. They can be very complicated and be many levels deep, so they can be sometimes really hard to look at. This display above here, just looking at the list itself, is kind of confusing and hard to see what's going on. This is a little bit clearer. But for very large list objects, even structure won't really show you what you want. But structure has one useful additional thing built into it you can use for big objects. Structure allows you to control how many levels of hierarchy you see at any given time. You can give it the argument max level. If I say max level 1, it shows me only the names and elements of the top level of hierarchy and hides the lower levels of hierarchy. This might be something useful to you for browsing lists that are particularly complicated, is to specify what level of hierarchy you want. There's some other features in structure that you can use to browse around a little bit easier too. It's kind of weird. Oh, so what's this? Where are the pepper kernels equals max level 3? The what now? I'm not sure what that means. Pepper kernels? What does that mean?
Sorry, yeah, we had an example of pepper kernels in a jar, and then there were like different levels, and I'm just wondering.
Yeah, so yeah, they would be, the top level would be looking at the container and being able to see the pepper, the packaged pepper. If you turned it to 2, you'd be able to see the pepper grains. So that would be basically, this would be like this jar, the overall jar. Each one of these is a pepper packet. And then within that, these would be like essentially granules of pepper. So typically, sort of like max level 2 would allow you, so these would be like, you consider this a grain of pepper, depending on if you imagine them as a sublist. Or you could imagine this as being a grain of pepper, depending on whether the object you're thinking of is like a list or not. It kind of breaks down when you're looking at the actual structures. It would depend on what you consider a grain of pepper. You might consider a grain of pepper to be an atom, like a atomic object that is nothing is finer than a grain of pepper. But you could then again think of a grain of pepper as being a collection of molecules, in which case then it is its own object. You could subset deeper in, and that you could subset into the atoms, and those atoms you could subset into their fucking quarks and shit if you wanted. It goes all the way down infinitely. Yeah, so it's like the abstraction breaks down, and you think about it too hard, as one tends to do. Okay, so next thing to do, select the 3rd element of the 5th element of list 4 and assign it to element 5.3 using double brackets. So the 3rd element of the 5th element. So what's the order of operations here? We subset to what first, and then to what? I have an idea how to do this. If you got it in words, that'll do. If you got it in code, that'll do. Ah, you got it in code right off the bat. Okay, so this says here, go to list 4, double brackets says, okay, this is the 5th element of list 4. If I display the 5th element of list 4, I'm going to get this whole thing, which used to be list 3. Okay, if I now say subset down to its 3rd element, so this is the 5th element of list 4, specifically the 3rd element of the 5th element of list 4, we should get 16. The reason for that is we've browsed down first into the 5th element of list 4, which has all of these elements. Then we browsed into the 3rd element of this, which is just the number 16. Okay, So this is showing you that, again, sort of an order of operations type thing. You can subset multiple times on the same object, and it does them in the order you write the subsetting functions. So start with list 4, get its 5th element. The result of that, you can get its 3rd element. If there were more sub-elements, you could keep going down until you've run out of layers to go down into. Okay.
I have a question
Yeah.
that I probably should have asked much earlier. When I knit, my code, it keeps saying that objects are not found. I can put it in the chat, but they're all things that I assigned earlier.
Okay. So what is the very first one that it can't find? Is usually where the issue is.
Mat big.
Mat big. Okay. So what you want to do. Oh, is it saying that when you knit or when you run the code in here?
Wait, can you repeat the question?
So are you getting that error when you press the knit button, or are you getting it when you're running it here in this thing we're looking at?
Oh, the second one. I
Okay.
get the error code in my console.
Yeah. Okay. So what you want to do is so wherever we are, we're right here. Go up here to this button that says run all prior chunks or run all chunks above. Run that, and then see if it fixes the problem. Because most likely the one line where Mat big was created just didn't get run. You should be able to see it. Once you press that button, you should be able to see Mat big up in your environment, like right there in the top right. Awesome. Okay.
Yes, thank you.
Yeah, that's happens to me all the time. Is I will have written something in my markdown. If I knit, it's perfectly fine, but I just didn't run it in this particular instance, and it's just there. And thus that button is one of my best friends. I'm always just like run all chunks of because I inevitably forget to run something. Okay. Last one. So what we want to do? Lastly, repeat the previous assignment of the 3rd element of the 5th thing, but just extract the element as a list rather than a scalar using the brackets and assign it to list 5.3. Change one thing from before. So here's a question, Jeff. I'm getting wrong object class and element 5.3 with the answer we had, but get the right answer on list 4. Wrong object class and element 5.3. Okay. Okay. So your question, I know what it is. If you display element 5.3, is it 16 or is it 16 in quotes? Unquoted or quoted. If it's quoted, okay, your problem is all the way up here. Is it this one right here? As dot numeric line 195. That's it. Was that it? Was this missing an as dot numeric all the way up there? Might check to make sure that this val 621 also says good job on val 62. It might not have run it. That would make sense. Make sure to run all ones above. Like I said, this button just solves problems. It's magical. And then see what it does. If it's still a problem, I can always just glance at the R&D and see what shenanigans it's up to. Yeah, because it should be numeric 16 rather than quoted, which goes all the way back up to that val 621 all the way up to the top. Okay. You know, I spent way too much time looking at this homework assignment when I know exactly where that is. Okay, yeah, check that after. Sorry, val 2. I'm trying to think where else. List 4, list 3, list 3, val 62, val 62. Yeah, that's the only place it could come from. Is it val 62? So if you display val 62 in your console, does val 62 have quoted or unquoted? If it's quoted, then it's definitely that as.numeric up there, and you'll have to verify that. Okay, so last one. Unquoted on vals. Oh, well, then what you need to do is rerun this line right here with list 2 and then look at list 2 and make sure it is also unquoted right here. And if it is there, then it's broken down somewhere around here. Now, yes, so that's what I was looking for right there too. So technically speaking, you get the same result between the two of them, but I specifically was looking for the single brackets one. So this one says, what we're doing here is basically the same extraction operations before. We go down to the 5th element. I had quotes where you said not to use them. Ah, jeeps. Tell you not to do things. Okay. So we go to list 4, subset to 5, but instead of subsetting to the 3rd element here like this, I'm saying subset with single brackets. Now, if we look at what this is now, notice it says $val6216. So the difference between this element 5.3 and list 5.3 is that this pops out as a list. So double brackets will give you the actual number 16 alone as a vector of length 1. This down here will give you a list whose first element is val62, which contains the number 16. So single brackets used on a list will return what is called a sublist. It will return to you another list which contains the things you ask for, which is kind of cool if you want to get more than one thing out of it, but normally is not what you want if you're subsetting an individual element. Okay. So that's all I want there. I'm knit all this, make sure I didn't mess anything up. Looking pretty good. Okay. Last section. Almost there. So what we got to do here, use data.frame to combine vecnum, the first column, and vecint, the second column, into df1. What does that look like? Miniature coffee break. Aha. I'll take it. Data.frame. Vecnum. Vecint. Okay. I'll show you this in the console. Looks basically like the matrix thing before. Vecnum, vecint. Like cbind, it gives you the column names. It looks basically like a matrix. Okay. So the next thing to do, use $sign to extract vecnum from df1, reverse it with rev, and assign it as the vector vecnum2. We can do this all in one assignment in one line of code. How do we go about doing that? First part of that is extract vecnum from df1. So how do we do that? Okay, we got df1 $sign vecnum. Okay, so we've got that. And then we just add on to it, right? That's exactly what we got the next one. So we reverse that with rev. Okay, yeah, right answers all around. So if I look at this, I'll show you. df1 $sign vecnum gives me vecnum as a vector. Extraction operator tends to spit things out as a vector rather than like giving it as a sub data frame. Then rev just reverses the order. First element becomes the last element, and so on. I've assigned that to vecnum2, and we're good. So the next one says, use $sign to add vecnum2 to df2 as a new column with the name number vector. Okay, I'll do that. So we got an operation. What we want to do is we want to take vec num2 from there and assign it to df2, but with the name number vector. How can we go about doing that? I can actually think of like 3 ways to do it, but there's a clean way. Oh yeah, I like to look at that. So this says we're going to say df2 $sign number vector. So this accomplishes the naming. df2, right? Whoop, back down here. df2 doesn't have something named number vector. If I just ask for number vector, it's going to give me null. This is a thing that doesn't exist. But if we assign something to what is essentially an empty slot, it will create it. What are we going to assign to it? We're going to assign Vectonum2. If I run that line, now I look at df2. Now df2 has number vector, which is the reversed version of Vectonum. So this is how you use the extraction operator to generate a new column, okay? Which simultaneously names it. Okay, next one. Combine df2 with itself using rbind to create df3. This isn't a trick question, but it might be an odd thing to think about doing. How would I do that? Yeah, I like it. Really just R binding something with itself. R is perfectly happy to allow you to give the same object as multiple arguments to the same function. It doesn't care that you're reusing it over and over again. It's perfectly okay with that. This just says take df2 and stick it on top of df2. The result of that is just going to be, this was the original df2. This is also the original df2. Now there's twice as much df2. Okay, just stuck it together. I think technically you could also, in a clunky way, do that with replicate, but that seems kind of unnecessary to me. Okay. Next one is a multi-part one. I'll extend this out here so it's a little easier to see. So what we are going to do is to create a new data frame df4 using the function data.frame that will contain the following named columns in order. Y will contain 20 numbers evenly spaced from 31 to 125. X has 20 numbers between 0 and 10 generated using runif. And color consists of 20 values sampled from callvec below using the sample function. Let's do these one at a time. We know we want data.frame. Okay, so how do I make something named Y in this data frame that contains 20 numbers evenly spaced from 31 to 125? Okay. Ooh, that's an interesting way to do it. We don't want to use the round here. Rounding is something we typically only want to do to display things nicely, like in an output document. I wouldn't round it. I would just stick with the sequence part of it. But let me see what that, oh, I see. Okay, let me see what, does that give us what we want? Sequence. There we go. Does that give us what we want? Oh, it does. Okay, so we can technically do it that way. That is not a wrong answer. It's just slightly more complicated. So again, what would be a way to augment this? So if we say y equals sequence 31, 125, what is the one thing we could change to make that a little bit from what we got earlier in this one? How could we change the fractional way there at the end into something a little bit easier? A long dot width. Length dot out. Yeah. Length dot out. A long dot width does remind me that we've got I think I've mentioned the sequence along function, which, yeah, there's way too many arguments. There's so many things. And so this is the thing about it, you get used to looking up stuff in documentation. It's impossible to remember it all. And so to something, it's like, if you know how to use this format, like right here, and do this fractionally, and you can't remember length.out, that's perfectly fine if that works for you. I just think that this probably eats up a little bit of time to do or think about. But yeah, the length.out is a useful one. So this is going to do, it should be exactly the same result, right? Yeah, exactly the same result, completely equivalent. Okay, so that'll do for us. We got that. So next, X that has 20 numbers between 0 and 10 generated from R uniform. So for this one, I purposely picked a function we have not covered in class. So if you don't know what that function is, what would be a good way to figure out how to use it? Yeah, I like it. Question mark R. You can look at it and be like, what is run if? R uniform. So these are different functions that pull from the uniform distribution, which just means the uniform distribution is just a distribution where every number in some range is equally likely to be pulled out of it. It's a completely random number, basically, assumes no distribution. So here we say R unif. It takes the arguments n and a minimum and a maximum. We go down to n, and n is the number of observations. Okay, well, we know we want 20 numbers. So I'm going to say x equals R unif, 20 numbers. I want them between 0 and 10. The next arguments are minimum is the first number, maximum is the second number. So as suggested in chat, 0, 10. Okay. You're going to get stuff like this when you run. Every time you run it, you'll get different stuff. It's a random number generator drawing from a uniform distribution. The values will never be below 0 and never be above 10. That's what you get. Okay. The next thing to do is color. Consists of 20 values sampled from callvec using sample. Okay. So how do we do that? We've created callvec right here. Let's see, I think I've created callvec. There we go. Callvec looks like this. It is every named color in the R language. There's a lot of them. Look, Dodger blue, dim gray, corn silk 4, chartreuse 3. There's so many colors, such a colorful language. Okay, so what we'll do is we just want to sample from it. I like the example there, pretty straightforward. We're going to say color is equal to, let's sample from callvec 20 times. If I run this in the console, we would get 20 randomly selected colors, different every time I run. If you want to shake stuff up, you have any something like that, sample is a good way to just kind of draw things randomly. Yep, absolutely. Glad you could make it. Okay, so I'm going to go ahead and knit this really quick and see what it gives me. Got to make sure that the answer check is correct on this one. Good job on DF4. Okay. Something you'll notice is if you run the check down here manually for DF4, it won't pass. Oh, actually, did I create the damn thing first? Let's run all this. It's hilarious how long sometimes this takes to run. There we go. Oh, that worked here? That's peculiar. Normally, the random number generator would result in that not working properly, but I won't question it this time. Okay, so next thing here, use cbind to combine DF4 and DF2 into DF5. What's that look like? Thanks for making it. Yeah, not a trick question. We can C-bind data frames together just like we do with vectors. So it just jams them right together. So df4 was all of this here with y and x and color, and then df2 was vecnum, vecant, number vector. As long as they have the same number of rows, we can C-bind them together, just like we would with vectors or matrices. Okay. Next thing down here, use data frame to combine df4 with df2. What's that look like? Once again, not a trick question. Yeah. Well, df2 instead of df5, but same deal. df4, df2. Okay. If I display this down here, we will see something. It looks exactly the same. So what's actually going on with data frame used on two different data frames and C-bind used on two different data frames, they are doing the exact same thing. They're in fact calling the same function under the hood. So if you give two data frames to C-bind, it doesn't, like C-bind doesn't go and bind them as matrices or something. It just sticks the two data frames together as if you put them into data.frame. So you get the exact same result here. Okay. And that is the entire thing. If I knit, it should say we have done a fabulous job on everything. I really should add a check at the bottom that if everything is correct, it just rewards you with a pretty picture or something like that. But I shall never teach this class again, so I don't have to worry about that. I can leave that up to Brian to do. Okay. Yep, so we are good. Okay, gone to the end. Not going to go over the word questions like I said. Make sure to ignore data frame question 1 here. Are there any questions anywhere, top to bottom through here? Anything you want to chat about? And if not, feel free to go. I mean, you're always free to go, but yeah. Yeah, absolutely. You have an error in parse. So what is it exactly saying down in your, if you got an error that's pastable, if it's coming from our markdown, sometimes it doesn't let you paste them. But if you give me the whole thing, if possible, I'll tell you exactly what it is. Line 339 from our markdown. So assuming it's the same thing as me, it says, can you paste the entire thing? Or if it doesn't let you paste, it'll be annoying. Sometimes it doesn't. Yeah, if you can find like the key part of the text, does it say that it can't find a function, can't find an object, something like that. It's almost assuredly a problem with this line, this code right here for the data frame. First text, source file text, and unexpected. Expected car sample. Oh, okay. So 27. Make sure this looks exactly like this. So that looks to me, if that's exactly what it says, it's just a typo where this should be colvec instead of colv with the extra V. But then also check that you have a comma here and the closing parenthesis here. that sort of error is typically a either a hanging quotation mark, like these ones should be either fully unquoted. Okay. Next one. What you got? Error in names, x equals false. Okay, so that doesn't say which line. So like 357, 380. You have different lines than me. Wrong object. Oh, message wrong object names. So that one is popping out. It's popping out on like this test here. Does it say which one specifically? So if you run like this, is it saying with like df5, df6? Problem with like this is like problem with df5, df2, df3. Okay. df2 number vector. So if we go up here to where we create df2, does your line look like this on 322 or wherever it is in your document? df2 $ number vector assigned to it like this. Make sure that's spelled correctly. Is that it? Should be that. Got it. Ha. Is it knit now? Sweet. There you go. Okie dokie. Yeah, you too. Okay, I'll shut it down. Let's see. Stop recording.